Let's have a look at question 6 in this video. So we have the test scores for an educational assessment of students are normally distributed with the mean of that population of 535 points and a standard deviation of 7 points. Now the proportion of students with a score between 531 and 539 is going to be 0.28. Okay, so what's the intuition here? When we speak about proportion, we also refer to probability. They're one and the same. Meaning, what would be the probability of students that can score the points between 531 and 539? So what we have here is distribution of points. But to find out proportions, we must standardize that distribution into the z distribution, because the z distribution is going to help us find that probability. So let's see how that works out. First of all, let's draw it to understand graphically what's happening here. We have the distribution of the points, which is normally distributed, right? It's going to look like a bell curve. So it's going to look something like that. And with the population mean, right, the mean over here of the entire population is going to be equal to 535. And we want to know the proportion of students, right, that percentage, who's going to score between 531, which is slightly lower than the mean. So here's going to be 531, and 539, which is slightly higher than the mean, somewhere over there. We're looking for this region. So this is the normal distribution of the points. Now, what we said, we're going to convert it. We're going to convert it into the z distribution. So let's see how the z distribution looks like. It's also going to be the normal distribution, but it is standardized. So what does standardized mean? It means that we're going to look by how many standard deviations are these points far away from the population mean. In other words, let me just say it once again. By how many standard deviations is 539 further from 535 from the mean, and by how many standard deviations is 531 further from the mean of 535. So we'll have 2 points that we need to standardize. Now in the middle, the mean of the z distribution, right, the standard normal distribution, is going to be equal to 0. Why is that? Because remember, the population mean at this point is 0 standard deviations away from the population mean. Hope this makes sense, because we're literally representing now the population mean. Let me try to show it with the formula. It's gonna make even more sense. The z value is gonna be equal to the difference between the observation minus the population mean divided by the standard deviation. So by how many standard deviation is this difference far away? By how many standard deviation is the observation far from the population mean? At this point, the observation itself, 535, is equal to the population mean, so the difference between them is equal to 0. That's why the mean of the z distribution is 0. We are 0 standard deviations away. Now the question is, how many standard deviations are these two far away from each other? Well, we'll do the same math. We'll replicate the z score for those two values by finding out by how far this number and that number, 531 and 539, is far away from 535 in terms of standard deviation. Now, before we finish the video, one more thing to figure out the intuition finally. Why is this standard normal distribution? What's so standard about it? The standardization happens because the units cancel out. Notice this. This is measured in points for our example, right? Several points here, and the standard deviation is also several points. So whenever we make the math, whenever we do the math, we have points as a metric on the numerator and points as a metric on the denominator, and they cancel out. So at the end of the day, the z-score is a unitless score. That's why it is standardized, so that we can apply it to any type of measurement, either with points, or we compare apples, or we compare dollars, doesn't matter. The units will cancel out. Hope this all makes sense. In the next video, we calculate these two, and then we'll use the z table to find out that proportion.